Hello and welcome to today's webinar, Accelerate VM and Container Workload Deployments with Rack-Scale Composability. Today's event is brought to you by Hewlett-Packard Enterprise and produced by Actual Tech Media. Before we get started, we have a little bit of housekeeping that we first need to cover. We'd like this to be a very educational event. We want you to learn as much as possible. And to do that, we encourage you to ask as many questions as you'd like using the GoToWebinar control panel. We'll have a dedicated Q&A session at the end of the event, so make sure you get your questions in early. We'll be selecting the best questions for that Q&A session, so feel free to ask questions as we go along throughout the presentation and the demonstration. We also have a handout that you need to download. That's in the GoToWebinar control panel as well there under handouts. That is the HPE Composable Cloud Solutions Brief, so make sure you just click on that and go ahead and download it right now. And then finally, we'll have a $300 Amazon gift card that we'll be awarding to one lucky attendee on today's event. That'll be after the Q&A session. So again, make sure you stay tuned for that drawing. If you're watching this event on demand, I'm sorry, the drawing has already occurred. And full prize terms and conditions can be found at events.actualtechmedia.com. My name is David Davis, and I'm excited to be the moderator on today's event. And with that, let me introduce you to today's presenters. First off, you'll hear from Mr. Andy Fisher, who's a worldwide product manager for HPE Composable Cloud Solutions, and Mr. John Christensen, technical marketing engineer for the software-defined data center and cloud group. Andy, John, thank you so much for being on the event today.
Great, thanks. Pleasure to be here.
Awesome, awesome. So before we jump into it, before I hand it over to Andy for today's presentation, we've got a couple quick poll questions that I first want to share with you, and I'll actually share the feedback so you can see, how you stack up with your peers on today's event. So the first question, it's coming up right now. There it is. You should see it. Simply says, "What's your primary use case?" And here we're talking about data center infrastructure, composable cloud. How would you envision using a composable cloud at your IT organization? And this is a single select answer. So virtualization, containers, hyperconverged infrastructure, bare metal, or maybe a mixture of, a couple or all of those things. So we're curious to find out why it is you're interested in this topic. What's your use case? I'll give you a minute to answer that question. And it looks like 32% said virtualization, 7% containers, not a lot of interest in hyperconverged infrastructure use case, 5% bare metal, and 57% said a mixture of all of these things, which I think is probably very realistic. All right, let's do one more poll question before I hand it over to Andy. And that poll question on the screen says, "What initiatives do you have in the next 12 months?" And this is a multi-select question, so you can select more than one answer here. And the answers are infrastructure migration, refresh, backup, recovery, DR, cloud transformation, new apps, data center consolidation, or security. So select one or multiple answers on that one. And then I'll share the results of this poll with you as well. I'd be surprised if there were any IT organizations out there that weren't doing at least one of these things at any one time. All right, looks like we got a lot of responses. Thank you, everyone. Let me share the results. And 50% said infrastructure migration or refresh, followed by 45% who want to improve backup, recovery, and disaster recovery. And then on down the line there, some great responses. Everyone is doing at least one, if not multiple things there on the list. And with that, it's time to introduce, well, I guess I already introduced Andy, but it's time to hand it over to Mr. Andy Fisher, today's first presenter. Andy, I'm going to hand control over to you.
Sounds great. Sorry, I might have been on mute before. Happy to be here. Excited to talk to you today about our expanding composable portfolio here. Let me see if I can get my screen up. Can you confirm that you can see it?
I do see it. Take it away.
Great. So we're going to jump right in here. So the way that this is going to work, just to kind of let you know what we're going to talk about, we're going to start at the top and talk about, some of what we expect your problems to be that you just kind of verified here, as well as the basics about the Composable Cloud product and solution that we have that we're quite excited about. And when I'm finished, we're going to turn it over to John Christensen, who's going to take you through some demonstrations of this thing being actually used. So, please stick around for that part of it. I promise I'll try to keep the marketing slides to a minimum up the front here. This is really pretty exciting stuff. So, just to kick things off, we recognize that the industry continues to evolve. There's increasingly complex requirements in a hybrid world, and new demands on IT, right? So it's on us as HPE to partner with you guys to make sure that we deliver the best, most efficient ways forward to enable you to deliver on those rising expectations. So specifically, we've kind of view that the industry needs to, free IT capital and productivity for innovation. So it's not about saving all the dollars in IT. It's about unleashing the capability of IT for your business. And so it's a combination of the four things indicated here. It's about speed and efficiency. How do we enable you to deliver apps and services faster, be more responsive to your business, drive higher productivity, and we want you to be able to scale friction-free, right? So you need to be able to scale on demand without disruption, and reduce the need for specialized skills here. We're moving to a kind of a generalist world here, with the ability to get things done without teams of different people with different skill sets. So we want to make sure that costs are aligned to consumption. That means lower overall run rate costs over the life cycle and getting more out of the people and resources so that you can be more efficient as your infrastructure scales. And we also want to enable choice and flexibility, right? So it's not up to HPE to dictate what you choose to run on our platforms. It's really on us to help you run those better. And so this is all about choice and flexibility. We'll get into that in a minute. And I was particularly, happy to see that there's a mix of environments out there, and this is what this is all about, to support those complex environments that are using your choice of stacks and environments. And overall, it's about adapting to changing business needs. So at the end of the day, we're kind of in the middle here between the old world with traditional apps that run on bare metals, containers and virtualization, and the more nimble world of cloud apps that are automated with DevOps, that are consolidated either in the public cloud or in a private cloud. And we believe that our composability is a key element to bridge those two parts of the business now. We recognize a lot of our customers need to operate on both sides, and we believe composability is the overall answer to work in both type of environments. So as you indicated, the majority of you showed that you had mixed workload environments or mixed use cases, and oftentimes we see separate projects with different workload environments or use cases deployed at different times with different storage, compute, and fabric, different management infrastructure, different higher level management stacks. And so what we really want to do is enable a world in which it doesn't matter what the mix is. You can deploy a standardized infrastructure, composable infrastructure that has consistent and very consistent infrastructure management, and can support not just one use case, but whatever mix that you want to use. And it's about attacking underutilized resources and becoming much more nimble and agile to deal with changes as you need to move between those environments, or even to repurpose from one use case to the other. And so that's one of the reasons why we're real excited about this. So just, our view of composable, the definition of composable overall is to have fluid resource pools. This is, means different things in different architectures, but it means disaggregating the resources between compute, storage, and networking, supporting both physical, virtual, and containerized environments, and doing auto integration of resource capacity, covered by software-defined intelligence that includes our powerful OneView management interface that provides template-driven workload composition and policy enforcement, as well as non-disruptive frictionless operations like firmware updates, as well as a very comprehensive unified API that allows a single line of code to abstract the functionality that's needed to assign the initial resources and to reclaim those and bring them back for other uses, and provide full programmability for today's DevOps environments. And so where that kind of benefits you is it provides more agility for your infrastructure, greater flexibility in how that infrastructure is used, improved operational efficiency, lower costs because of that improvement in efficiency, and overall just better responsiveness to your business. So it's about the software-defined intelligence, fluid resource pools, and unified API. Here's a few quick examples of some actual customers that have benefited from composability over the last few years here, and they're seeing significant reductions in the amount of infrastructure, the time it takes to deploy container solutions, or to do basic maintenance, but important maintenance updates like firmware updates, and in general, just increasing uptime and reducing downtime. So these are examples that are specific to Synergy, but they apply to what we'll be talking to today. And it's also important to note that HPE has developed really a very open platform and an ecosystem of composability with many partners here to enable DevOps environments and automation. And this is driving increased adoption of HPE OneView. We're well over 1.25 million licenses now. It was CRN's 2018 Product of the Year, and we're over $1 billion run rate with Synergy. And that's just the start, as you'll see here. So it's not just about having an HPE specific solution. It's about being able to interface with the rest of the world and the other tool sets that are out there based on the choices that you made, that you need, and we want to enable full automation through. So moving on. So what we're really doing here is we're expanding our composable portfolio from just a simple, just only a bladed infrastructure, specifically Synergy, to rack infrastructure with a common OneView management and API experience. And this can, basically brings the similar management experience, very similar managed experience, in many cases identical to rack infrastructure, which has been a very difficult problem to solve historically. We think it really opens up significant possibilities here. And of course, this can be delivered as a service with our GreenLake Flex capacity. So you can buy either blades or racks now with composable capabilities, either as your on-premises infrastructure through normal purchase process, or you can also buy it as a service and through consumption of GreenLake Flex capacity. So specifically here, we're really bringing that composable experience over from the Synergy bladed architecture to the Composable Cloud, to ProLiant DLs. And so it's important to understand that a large percentage of the market buys discrete rack servers, and the value of the composable capabilities that we have in Synergy are so compelling that we have been pursuing how to enable rack mount or DL servers for quite some time. we made an acquisition last year, a company called Plexi that does software-defined networking. That's been renamed the HPE Composable Fabric, and we'll be talking about that. So what is HPE Composable Cloud for ProLiant DL? So it's really pretty simple. It's standard HPE rack servers with almost any option configuration. So one of the key design tenets for us is that we did not want to have a separate server model or any special software that needed to run, or even really any limitation on option selections from which chassis you use to CPUs, memory, hard drives, what have you. Today, the Composable Cloud solution really only has one modest restriction on the configuration of the servers that we support, and we'll be getting into those specific models in a minute. And all that restriction is that you're required to have a specific FlexLOM embedded LAN on motherboard that is one of our standard 25 gig networking cards is in the server, so they can connect to the new Composable Fabric. So I'll call those out in a minute, but this is standard ProLiant running pretty much any workload you want, any operating system. This is not a special version of ProLiant. This is no extra software, no different firmware. You run whatever you want on the platform. This is a composable rack infrastructure to improve your overall efficiency of your environment. It's then combined with the Wire1 software-defined networking fabric that is now called the HPE Composable Fabric that came in as part of this acquisition. And fundamentally, this is the ability to own both ends of the networking wire within the rack. So this is about rack level, row level fabric, and optimizing that for mixed load workload and composable workload environments. So in order to provide a full end-to-end automation on rack servers, you have to own both ends of the wire within the rack to give you that programmability. And this is all capped off with a OneView experience, same version of OneView that you use today, with some additional licensing to enable the features. And it really delivers the very similar, almost identical experience that we have today on composability with HPE Synergy, with full APIs to standard ProLiant DLs. And so why is this important? This is fundamental, because what it does is it takes rack servers, I kind of believe, out of the dark age, because it bridges the gap between having these islands of compute and storage and brings them into a model where you can fundamentally deliver infrastructure policy deployment, enforcement, and automation that you can't do really any other way on rack mount servers. And so this is this very difficult puzzle piece to fill that provides the foundation for putting scalable end-to-end automation on HPE rack servers at scale with those HPE composable ecosystem partners across many use cases. So we're quite excited about this, and for customers that are, for whatever reason, are committed to a rack server form factor, this provides the HPE composable experience that we now offer, previously only offered in our bladed infrastructure. So here's a quick picture here. I've kind of covered some of this as well. You can, I'll get into how you buy this in a minute. There are some optional components. You can, there are deployment services you can get from HPE PointNext, but those are optional, with the exception of a basic service to set up the new Composable Fabric. As I said, this is really the combination of OneView, the Composable Fabric, and standard ProLiant DL servers. We also support HPE InfoSight, which is provide predictive analytics for the servers in the solution. That's a free license that you can activate as part of the solution, and you can consume this through normal acquisition or through HPE GreenLake Flex capacities to get cloud economics. And there's a variety of workloads workloads and use cases that we'll talk about in a minute further here. So a quick snapshot of just the facts here. This is currently supported on our ProLiant Gen 10 core platforms, which are the DL360, the DL380, the DL560 Gen 10. So we have both 2-socket and 4-socket, as well as we now support the SimpliVity 380 Gen 10 for customers that are interested in running SimpliVity in their environments. And we also support the DL380 vSAN Ready Node All-Flash 6 model that recently came out. I will note that you can configure the DL360s or the DL380s to any published vSAN Ready Node configuration. That last one there is for ordering simplicity, but you have full capability in a VMware environment to deploy whatever, we have a wide range of vSAN Ready Node configurations that are published for the 360 and the 380. The top-of-rack fabric illustrated on the right there is the new HPE FM3180 connectivity modules. Of course, you'd have 2 of those per logical rack. When I say logical rack, we're not forcing you to use a certain number of servers per rack. There are 40 available ports. John will talk about that in a minute. There's 40 available redundant ports per switch pair. You can cram a bunch of servers in a rack if you want and consume all or most of those ports, or if you want to distribute those servers over 2, 3, 4 physical racks, depending on your power and cooling density or what other limitations. All you need to do is get some additional longer cables to optimize the port density on those top of rack switches. So I will make a comment. This is standard industry networking hardware. There's nothing to be concerned about here. This is very compatible from a protocol perspective. Same industry standard chip in the inside. It's really the fact that we have a software-defined layer on top of it that provides a lot of the extra composable fabric value. We also have a passive optical interconnect. John will get into this more in a minute. This is one of the most exciting things about the Composable Fabric, is that it allows very simple, very rapid, very easy expansion of the network and the fabric from rack to rack to rack. So you can build very large clusters that are running mixed workloads, but then can have direct communication with very large high bandwidth connectivity without going through the leaf and spine network. From a server perspective, I mentioned before, you need to have one of our standard flex LOMs. No special sauce on there. It's the standard NICs that you may already be buying with these servers anyway. There's the Broadcom-based 631 FLR and the 640, which is the Mellanox FLR version. So that's the only configuration restriction right now, is that you have to have one and only one of those two to connect up to the Composable Fabric. So you have a redundant 25 gig connection from each server, as well as an ILO connection to a standard 1 gig switch. So from a storage perspective, you can do pretty much any software-defined storage. We have some specific benefits with vSAN, but if you want to do Gluster or OCS on OpenShift or Kubernetes, you're going to be able to do that. Right now, we're working to support Azure Cloud Storage. That's a future roadmap item, just due to where we are, but wide capability to enable the large spindle count on these platforms, so that if you're trying to build a large software-defined storage fabric, you can do that, and you've got the bandwidth and the performance to do that. We also support fiber channel storage versus optional fiber channel HBAs. So this is separate fiber channel fabric, switches and so forth, but if you have a legacy SAN that you want to connect to, whether it's HPE's or somebody else's, you can do that. And of course, we support local hard drive and SSD, sorry, typo there, as well in our platforms. And you'll see the storage choices expand over time. From a scale perspective, we currently support up to 240 servers. That's 6 of those logical racks or 6 of the FM3180 switch pairs, each of them up to 40 servers per logical rack. That's where our scale is today. You'll also see that expand over time as we continue to develop that. And as we've mentioned already, lots of use cases, mixed use cases supported here across those clusters. If you do have an environment greater than 240 servers, it would just involve an additional instance of HPE OneView and the network management that goes with it to support additional pods of 240 servers, which is the scale that where we are today. So moving to the next slide to talk about use cases. This is a very versatile platform. It's really composable rack infrastructure. We recently validated that we support VMware Cloud Foundation, as well as our core use case that we came out with initially of VMware ESXi with vSAN. John will talk about some of the value-added features in the vSAN environment that's quite exciting with the Composable Fabric. We also believe that containers are important, and we currently support Red Hat OpenShift, and you'll see additional choices there going forward. We support hyperconverged infrastructure with our new SimpliVity 380 offer, as well as bare metal. So you can bring your apps, your OS, you can bring fiber channel storage, and if you want to do this through the OneView API or user interface, you can do that, or you can do DevOps with our ecosystem partners through our full API. So this is about transforming new or existing Gen 10 servers to composable infrastructure. In fact, I'm going to go to this slide, and I'll go back here, is that we recently changed how you can buy this. So initially, we started in the bottom right side corner there, where in order to get the advantage of all these capabilities together, you needed to buy it as one big package. You needed to buy the servers, the fabric, the licensing, and the services to deploy it. We got feedback pretty quickly that that was too restrictive. And so mid-year here, we announced the ability to not only support new Gen 10s, just that customers are buying, they can add the extra components and layer this on top, which is the top right box there. But we also now support upgrading those Gen 10 server models if customers are interested in doing that. So this isn't rocket science. This is standard rack and stack, top of rack cabling. It's installation of some pretty standard management stack stuff, such as OneView. Pretty easy to do. In fact, we've got materials we'll talk about in a minute to enable you to do both of those two ones. So we've really created a very flexible purchase model now. And if you're interested in starting to add this to your new servers as you deploy, you can do that and roll your own without a bunch of services that you might be able to cover yourself through your own expertise, or even go in and retrofit your existing Gen 10 servers to support this. So quite excited about that. So just going back a couple slides here. Sorry. So wrapping up here before I turn it over to John. So at the end of the day, this is about providing a few things. First is software-defined control. So we want to be able to automate the infrastructure, specifically rack servers, through template-driven processes and lifecycle management with compliance. And John will go through this specifically, and including one of the things I'm quite excited about is the ability that within a rack cabled environment, being able to do continuous cable validation and alerting if anything changes in that supposedly wire once environment, right? So the idea here with this is you should wire these servers up to the fabric once, and all network changes then happen through the UI or the API. But as we know, human beings oftentimes make cabling mistakes. And so if someone messes with it later, intentionally or otherwise, you'll be alerted immediately and be able to bring it back into policy pretty quickly. John will go through that. So open APIs, mentioned this several times. This is central to enabling a fully automated scriptable environment all the way up as far as you want to go in the cloud stack, right? So this is about integrating with your existing tools and providing that surface so that you can script this to your heart's content. Of course, this is an integral part of this that I've mentioned is the HPE Composable Fabric. This is a software-defined fabric for the rack row level that allows you to easily scale and automate the configuration of networking within and across racks. So, this is what enables that physical wire once architecture and bridges that important gap so that we can get to a world where we can fully automate the DL environment. And lastly, we've got AI-driven operations that's coming in through HPE InfoSight, and you'll see that being built out as we go that provide predictive analytics to help deal with problems before they occur. Okay, so my last slide before I turn it over to John here, at the end of the day, is we want to automate your IT operations, specifically in a standard rack server environment to help you deliver apps and services faster. We want to help you compose and grow cloud infrastructure resources at enterprise scale. And this is to protect and modernize your existing environments or your new deployments of Gen 10 servers as you go forward. So ultimately, it's about simplifying the data center rack connections with software-defined, automated, and intent-based networking. So you can go from days versus months in deploying your infrastructure, going to minutes versus hours to when you try to scale, and also have massive improvements in deploying your network in a much faster speed, as well as just being more nimble as changes occur in VLANs or networking connections. You're giving the power over to the system administrators where they can now, either through the scripts or the AI, make real-time changes to deliver services and workloads faster. So with that, I'm going to turn it over to John to do a demonstration and get into some of the more details that I covered briefly.
Great presentation, Andy. Before John does his demo, I have a quick poll question for the audience. That question is, what are your obstacles to achieving the initiatives that you said you were interested in the previous question? So this is a multi-select question. You should see it on your screen now. And the options are budget, lack of internal skills, organizational resistance to change, migrating workloads to the public cloud, or just lack of time to innovate. And I'll share the results of this with you. And take a look at that. 76% said their biggest obstacle to achieving their goals or initiatives is their budget, limited budget. I assume it's not too much money in the budget. It's always limited budget. So interesting responses there. 30% said lack of internal skills. So good feedback. Thank you, everyone who responded to that poll. And with that, I'm excited to turn it over to John. I know he's raring to go with a demo.
I sure am.
Awesome. All right, I just gave you control, John.
Yep. Hopefully
Excellent.
You can see my screen.
I do. Take it away.
Cool. Well, hello, everybody. Just to remind you, my name is John Christensen from the introductions earlier. I've put my name and email address if anybody wants to contact me directly for more information on this title slide. So what I'm going to do now is I'm just going to go through a couple of slides to, if you will, flesh out the architecture, which will then help the demo that I've captured, explain how we've built this and how you manage it on a day-to-day basis. So for those who want my email address, it's going to disappear now. So quick positional slide. Again, we're talking around composable and how we're bringing those capabilities to our traditional, discrete rack mount servers. One of the things that I'm going to carry on or pick up from Andy's presentation, he said that roughly 89% of the server infrastructure that's expected to be purchased over the next couple of years will be at the discrete form factor. There's a few dynamics in that. One of the big things that we're seeing is basically a customers moving to software-defined storage personas. So that could be SimpliVity, vSAN, and any other ones, right? So, and again, and Andy referenced that earlier. The reason why I want to bring it up is it's probably a slightly different operating model to a traditional infrastructure. And it's a slightly different operating model to what we've done with Synergy, because the premier experience that we have with Synergy is the idea of composing and recomposing as needed. Typically, when we talk about that, we mean in terms of the compute nodes. In the compute node, I don't have any localized storage. I will be connecting out to a storage array, ideally a HPE storage array. Why is that important? Well, if I think about composing and recomposing, anything that's on that node, I'm going to destroy, right? So I'm going to go, when I go and rebuild that node, if that's providing storage services into a cluster, be that a vSAN cluster or a Ceph or a OCS on cluster, if I go and destroy that node, that means I have a cluster action, which is to copy all the data off, and then do some rebalancing, either automatically or manually, to make sure that the data is copied across the cluster. Now, depending on the technologies you use, depending on the size of the nodes, as in how many drives you have or the capacity of those drives, is going to dramatically impact how long those tasks take. So it's not uncommon for some software storage personas to take days for those tasks to complete. So what we normally see when customers are looking at the discrete server form factor, going after these kind of software-defined everything, and by that I'm talking about virtualizing the compute, the networking, and now the storage of those nodes. When we talk about those kind of characteristics, we typically see customers, they normally expand them, or they will rebalance them. In other words, if I've got two vSAN clusters, I may have to take one node out of vSAN cluster A and move it to vSAN cluster B, as long as they're the same hardware profile types for performance and resiliency, right? So we'll see people move nodes. We don't necessarily see folks repurposing a node. So we wouldn't necessarily see folks go in and say, okay, I'm going to take this asset which I've licensed up that's got storage as part of a cluster, and I'm going to churn and burn that guy. And today it's a vSAN node. Tomorrow it could be say a Red Hat OpenShift node running Gluster, right? So we normally see customers, in the mode on the right, when we talk about composability, they're looking at how they can expand quickly. Now, when we look at in that space, we often find that there are challenges, and it's typically these are age-old challenges, and Andy mentioned them through his section of the presentation. But it's typically the things where, hey, I need to move fast, I need to add more capacity into my cluster, regardless of what that storage persona is, but I need to add more capacity. I plug the server into the network, and then potentially there's that the handoff, or there's the, as we call it here, maybe a little bit of operational friction when we're trying to define and agree what the network configuration needs to be for that new node. I may have multiple clusters in my environment, and they all may have slightly different networking sets of the numbers of VLANs, all that kind of good stuff. So that can be a manual process. And we mentioned over time where you could have like configuration drift, and I'll put my own hand up, even though I have a lab infrastructure. I often have to go into the data center to identify which server is connected to which port in the network, and then what the configuration is on that port once I've identified it, because I need to make some changes. So that kind of operational friction, if you will, we eliminate with this solution. So the key thing here is we're looking at bringing together the infrastructure and the networking world together for the discrete servers for the first time. And all of this capability is presented up into one view. So this basically means from a server infrastructure side, we're radically simplifying the bring up process of that infrastructure, of those clusters. It means that reducing the time it takes to do all those things, and we're given full end-to-end visibility. On the other side, and Andy mentioned the networking acquisition we made last year, and we'll go into a little bit of detail around that architecture. This is pretty innovative in the approach within our Composable Fabric architecture. We have this solution now within. This networking capability within our solution that is a meshed fabric. So I no longer need to define the VLANs on each rack. It's done at a fabric layer. So as I span across racks in my data center and ultimately rows in my data center, I'm not having to define the networking at every endpoint. I'm treating that as a complete meshed fabric. So it's a single control point into those. The other cool thing is that we have standard networking coming out, going up into the core network. So we're kind of simplifying that network layer. It's a spineless architecture, which we'll look at on the slide in a little bit. But the cool thing is it helps us to automate a lot of the tedious functions. And again, we're taking advantage of one view, talking with Composable Fabric to unify and present all of that up in one console. And again, there you go. I've kind of gave you the prelude there. So we're managing all through HPE OneView. So let's kind of have a quick duck under the covers. So Andy mentioned the switch. This is a view of the 3180. The 40 ports on the left in the I guess in the light blue, those are the server-side ports, and HPE OneView manages the configuration of those ports. So basically, as we'll see in a demo, we'll define a profile, and when we create that, OneView is going to go and instruct Composable Fabric Manager to basically configure the ports that server is connected to within the fabric. And again, it's any port that the server is connected to in the fabric. So regardless if I have a 1 logical rack configuration or 6 logical rack configuration, I'm going to do the same thing. I'm just going to say, I will need to deploy a profile against this server. And OneView and Composable Fabric Manager together will identify which ports in the fabric that server is connected to, and we'll configure those, and we'll apply a policy for the life of that server if you want to make any changes. The block next to it, so here in the orange, these are the uplink ports that you can use to connect into your core networking. One of the things that we're also seeing is as we're moving more to mass virtualization, and we saw at the beginning there's a few folks interested in containers, right? We're also seeing that when we start deploying this infrastructure at scale, so I've got 120 servers, 240 servers, and then I multiply by how many virtual machines or containers. When you do the math, that's like thousands of MAC addresses that's going to be coming up into the fabric, that if it's a standard layer 2 connection up into your core network, you've got all of those MAC addresses coming up into the core network. Within Composable Fabric, we have the capability of BGP or OSPF or virtual private cloud routing. So we can create layer 3 domains within Composable Fabric. So again, why is that important? Well, we stop that pollution, if you will, of MAC addresses coming up into the core network. So that means that we can just advertise routes or what address ranges are available either side of the link. The purple ports that are here, the fabric ports, this is how each switch talks to one another in the fabric. The key thing here is that you don't have to configure the fabric. When you plug the when you plug the switches in and you connect them to each other in the fabric, following the wiring guidelines, the switches auto discover each other, right? And the real cool thing is that we don't use spanning tree within this environment at all. So you bring the fabric up, it auto discovers itself, and then we use Composable Fabric Manager, which we have in the demo, that then talks down to the switches to configure them. All of the policies are pushed down to the switches. Composable Fabric Manager doesn't get involved in the routing of the traffic. That's all done within the fabric. So what does this look like if we're going to kind of use this live? So I've got 2 slides before the demo. So at the top, we've got our Composable Fabric switches. Everything's connected via an out-of-band network. So we've got an out-of-band management port on the switches, and we've got a traditional ILO on our servers, and they go to a 1 gig switch. Andy mentioned this in his session as well. Now, it doesn't matter how you then address those interfaces. If you are on the same network or VLAN from a management perspective, or if you're routed, as long as you have IP connectivity to the switches and to the ILOs, you can manage the environment. Again, we're really pushing hard here that we're doing standard infrastructure configuration and setup, which is, we've got our out-of-band management for our servers, out-of-band management for our switches. Right, and then depending on what your management infrastructure is, if you're VMware, if you're Red Hat OCP, or any other operating system that the DLs are on the hardware compatibility list for, you can talk to those servers. So this is the outbound management side. On the production side, Nick, we mentioned that we have this flex LOM, and you have a choice of 2. You've got the 631 adapter or the 640. So that's basically the 631 is a Broadcom chipset. The 640 is a Mellanox chipset. They're a 10/25 gig. All of the ports in the fabric the servers connect to are 25 gig. So that's aggregate 50 gig. In the fabric, and you can see these are standard industry cables connecting up into the switches. We're not doing anything from an infrastructure perspective that is different. As Andy said, we have our only requirement is for a single dual port 25 gig adapter. So that's kind of, if you will, the canvas that the demo is being created on. We mentioned that we can scale. So once we go outside that one logical rack unit, so this is, if you will, kind of like I want to say a marketing slide. By that, you can see there's not 40 servers here. So if you imagine that we had 40 servers, as Andy said, this could be 3-4 racks, depending on power and cooling and maybe even weight restrictions in a data center environment. The key thing is that all those 40 servers would connect up into a pair of FM3180 switches. Now, to scale this environment, we add in the FM1000 switch. This is a passive fiber pass-through module. So then you connect all of the switches up into the FM1006, and this is basically how you scale out your environment. To get to 6 racks in a single management domain, we have basically 2 sets of 3 logical racks, and they connect together over the FM1006. So when you scale, once you've got the FM1006 in your environment, which is a completely passive optical device, in other words, there's no configuration, there's no power, there's nothing that you need to do apart from plug the switches into the correct ports of the FM1006, and this is how we create this kind of mesh fabric. So I talked a little bit about that, and I'm not going to go into great detail here because we've got very limited time, but we said here we got the 6 racks, 240 servers, and we have this meshed architecture. So if you will, if you kind of see this on the right-hand side, if I've got these servers in rack 1, which are connected to switches 1 and 2, if you see all the connections, switch 1 is connected to all of the switches in the fabric via the fabric interconnect ports on the switch and by the FM1006. So you may say, well, you only showed 6 connections for the fabric ports. Those fabric ports are 100 gig with 4x25 gig ASICs. So when you look, that's how we can mesh the fabric across all of the switches. You can tune that as well. The key thing is that we're meshing all of the connections, within the environment. So if, for example, a connection goes out between switch 1 and switch 8, it's only one hop away from a neighbor. So it only needs to go from switch 1 to switch 9 to get to switch 8. So this is a meshed resilient fabric. If I had 12 switches in a fabric, I manage that as one big logical switch. And we've got the software-defined infrastructure, both from the Composable Fabric Manager and from OneView, to basically configure any of those ports for any server that's connected, because we own both ends of the wire and we know where everything is within our environment. So let's quickly go through a few demo scenarios, and this is a recording from a live environment, but I've put it into slides just so it's easier to kind of manipulate in a demo like this. So for those folks who are familiar with OneView or have seen OneView, this is our infrastructure manager for HPE servers. We also manage our 3PAR, Primera, and Nimble as well. We can manage those through this environment. The key thing is, I'm going to go through and look at my server profile templates. I have one called vSAN Ready Node, and all I'm going to do is deploy a new server profile. I'm just going to give it a name. Then I'm going to choose the hardware type. In my environment, I've got one server hardware type, which is a DL380 Gen 10. It already has the definition for firmware. It also has a definition for network connections within the environment. And it's a simple case of creating it. So whilst this is being created, I'm not having to specify to the network team which ports these servers are connected to and then ask them to configure the VLANs for this cluster. That's all done automatically as part of the policies that we're applying that have been defined in OneView. Now, if I click through and look at my connections, I can now go through now, and so this could be like day N+, and I'm thinking, okay, do I have a network issue? Am I connected in the right way? I can come through now. I can expand my network connections for that DL. So I'm looking from the server side. What does the network look like? I can see that I'm connected to a logical rack. So that's the name of my logical switch. It's made up of two physical switches, the A and the B. I can see the port it's connected to. I can see the network set that's supposed to be plumbed, so cluster is the network set. So that's from the server side. I can now click on the logical rack, and I can see from the network side now the configuration of the switch. So if I click on switch A and scroll down, I can now look and see the configuration of the ports. So I can see the connector type, what's on the remote end, so I can see that there's a server, the VLAN IDs that are passing, the profile. So, so I've said this network cluster, host profile 1, all this information is now in OneView and it's real time. In other words, if I make any changes, it's dynamically updated in OneView too. So that's where when we say, we own both ends of the wire, we can see from the server side and we can see from the network side in OneView. If I now move over and transition to Composable Fabric Manager, I can look at my configuration and ports, and I can see how it's being configured. And as you'll see, these ports are managed by OneView. If I were to make any changes in Composable Fabric Manager here, when OneView, I'll get alerted in OneView, and I'll just go straight through and I can say, okay, reapply the configuration so it matches the policy that we set in OneView. So again, this is only for the downlinks. I can create the uplinks or the connections to the core network via Composable Fabric Manager. So this is end-to-end network creation, and I'm conscious we're coming towards the end of the session. So what we're going to do is we'll create a network, call it production 2, define a VLAN, and then when I create it, I can automatically add it to a VLAN set. So we're going to use cluster as the VLAN set or network set, and I click on create. In OneView then, I'll go to my hypervisor cluster profiles. This is where we now know within OneView that the hosts we've defined are actually part of a VMware cluster. I can go in and see that the cluster is being changed, and that's because by adding that network, it's inherited, creating the network, adding it to the network set, that's inherited in the server profile template, so it knows that there needs to be there's a modification. When I come through here, it'll scroll down, and I can see the configuration of my network. And that this port group's been added. And you see now that my full hypervisor profiles have gone inconsistent because we've modified the policy for this hypervisor profile cluster, and we now need to make changes. It's a simple case of just coming in here, reviewing what's going to be modified. So we're actually going to modify the distributed switch in the vSAN cluster and then click to update. So as part of this policy, we added a new network into OneView. It was added to a network set, which was used by a server profile template. And by that one action, we're going through now, and we're going to change the policy on the ports in the Composable Fabric Manager, and also on the distributed switch in the vCenter environment. So you see now we went from adding 1001 to 1002 has been added into the network set. Again, this is how we're kind of managing the network policies within an environment. I'll look at my visualizations and hosts. So this is a unique feature where we can see all the way through to the guest networks and the guests, which port group they're assigned to on a distributed switch, where the uplinks go through on that physical server to the physical ports in the infrastructure. So if you will, we're getting to that signal in the noise where somebody says, hey, I've got this VM, I don't know how it's connected. You know, over here on the search capabilities, we can isolate we can isolate from a search perspective that virtual machine, and then find its path all the way through the fabric to identify if we have a problem or if it's connected to the correct VLAN. And then we can remediate that in vCenter. The last demo, which I'll go through real quick, this is the one Andy mentioned around cable validation. So in this scenario, I've gone through and I've performed a hardware upgrade in my cluster. I've added more memory. I come back and I check, and my OneView instance has gone red. I've got a problem now in my environment. When I go and check, I can look at the error message, and it tells me that there's a port failure in the fabric, but I'm pretty sure I connected the servers back up into the network. When I click on connections, I can see that I've got a red error on the logical rack. So if I click on the logical rack, it will tell me then that I've misconfigured the fabric, and in fact, I've actually plugged it into port 8 on fabric A. So if I click on that guy, you can see where the server's meant to be resilient network connection, so across two switches, I've cabled it back into the same switch. And these are the challenges when we go to the software-defined everything world, or certainly when we bring the storage into compute. These are real challenges for that configuration drift. I can go back now and run into the data center, basically make the changes to the environment, put it back into port 4, and automatically, when those changes have been done, OneView will reconcile and identify that the problem's been resolved, and that I can see that my connections have gone back to how they should be. So on switch B, I've now got the second connection as I should have. And it's always good to finish a demo back on the main page with a nice green, healthy environment for that. Finally, just as a kind of reminder, if you go to hpe.com/composable cloud, you'll find more information about Composable Cloud. And hopefully through the demo and the conversation we've had with Andy as well, you can see how we're expanding composable capabilities across our portfolio. So we're really building out that composable strategy. With that, I'll hand back to David.
Yeah, great presentation, John. Thank you, Andy, as well. While we do some Q&A here with the audience, I'm just going to pop up this poll question. I know we are quickly running out of time. The poll question says, I would consider this solution for my next project. The answers are yes, absolutely, and there are others as well. So just select the question or the response that correlates to you and your opinion. We appreciate that. Let's quickly do some Q&A here. First question that came in, they're asking, like, what's the entry point with this? Where do I get started if I just, want to purchase, let's say, the smallest configuration possible?
So it's a great question. So you're able to order with as few as 4 servers. However, that would only be really applicable for a proof of concept or something. This is really intended for rack row scale. So unless you have an environment of say 16 to 20 servers, it's hard to overcome the economics on the top of rack composable fabric just because we've got a pretty beefy fabric there. So this is really intended for optimization at scale. So, but you don't have to have a full rack, but once you get to 16 or so servers, it will make more sense economically, but you can order with as few as 4.
Okay, nice. And for everyone out there, I just posted a URL in the chat box for more information on the Composable Cloud. Make sure you visit hpe.com/Composable Cloud. Another quick question here. Can I do this with existing DL servers?
So you can do it with existing Gen 10 servers that are on our support matrix. So those are the ones that we talked about, the DL360, the DL380, the DL560. So if you have those servers and you have to have one of the 2 NICs that we indicated, but this has some dependencies on the current generation of ILO, and which case started with Gen 10. So this is a Gen 10 going forward. But you can retrofit any previous Gen 10s with ILO 5 that you previously deployed.
Okay, very nice. And then another question, how can I try this out? Is that possible?
Yeah, so yes, it is absolutely, right? So we've got some canned PowerPoint walkthrough things that cover some of the stuff that John did that we can make available, but it's really to go through your rep or your sales partner, and they can set up. We've got a virtual sandbox on a real system in our demo center in Atlanta that you could schedule time on to actually use this. We also have some hands-on labs that you could use as well to kind of walk you through some of the things that John covered. So yeah, different opportunities there, but best to go through your sales partner there, either HPE or one of our channel partners.
Excellent. Well, I think that's all the time we have for live questions. A lot of great questions coming in. Thank you, everyone, for those. Before we go, I want to announce the winner of the Amazon $300 gift card. That's going to Christiane Nelson of Ohio. Christiane Nelson of Ohio. Well, this has been a great event. Thank you so much to HPE. Thank you, John and Andy, for your great presentation.
Thank you. Appreciate everybody hanging in there.
And thank you, everyone in the audience, for joining us on today's event. Again, for more information, just click that link in the chat box, hpe.com/Composable Cloud. Have a great day. See you next time.